Hi fellow enthusiasts, welcome back to part 2 of this video. In part 1 we demonstrated how we can breadboard our design preamplifier. So we designed this preamplifier on the multi-sim simulator, and we ran the simulation and showed that we're getting good amplification. If you can see this, the signal here, we have good amplification. So it's about 2 volt amplification we're getting here. So what we're gonna do now is to convert this, like we said, into an oscillator. Okay, so to do that, this is what we're gonna do. We're gonna visit the principle one more time. So I'm gonna put up the block diagram. Look at there's the block diagram. You have an amplifier. We're gonna add a frequency determining network, and then we're gonna add a feedback network. So to this amplifier, to do the modification, let's see anymore. So this is basically the amplifier without the input circuit. So we're gonna rearrange this resistor. So same circuit we had before, and the capacitor, we can actually pull this in. There's no point putting it out there. Then we can have this is where we're gonna do the magic, right? So we're gonna put, as a frequency determining network, we can put an inductor. Okay, so let's have parallel resonance, right? So basically we have parallel resonance. We can change this value to a variable capacitor if we want. So let's just have this schematic full screen and change one of these to variable capacitor. Let's change the symbol. Okay, make it variable capacitor and leave the other one as fixed value. So basically this is the frequency determining network, and to put our feedback network, we can just have a capacitor connected across this way. With this circuit the way it is, we have just built ourselves an oscillator. So I'm going to put up the circuit diagram of the oscillator, and we're going to go and breadboard what we have just created right now. So we have the preamplifier. What I'm going to do is to connect the frequency determining network across the base collector resistor. So in this case, we're going to use a crystal. We have 27 megahertz crystals, so we're just going to pick one of them in this simulation. So alright, here's a 27 megahertz crystal. So we're going to use that. We're going to put it across the base collector resistor. Alright, there's one thing. So we're done with this side. And then the next thing is to connect a capacitor across the emitter collector region. So we're going to connect this capacitor. Right here we're using 5 picofarad. The other circuit we built, we use 27 picofarads. So we're going to try 5 picofarads here. In the meantime, I'm going to make way for the 5 picofarads to go in. Alright, so it's going to be challenging, so I'm going to try to fix 2 in one spot because we have limited real estate to plug in all the components. Alright, so let's just make sure that amplifier still works. Alright, so now we're gonna plug in the capacitor. Alright, we have the capacitor plugged in, and it still functions as an amplifier, as you can see. Now, how can we test this and see that it's actually an oscillator? We're gonna turn on our software defined radio and see how it works. So we're gonna turn it on. Let me get a software defined radio. We're gonna turn off the image. So software defined radio is gonna come on right now. So let me just pull it up. Right, so the software defined radio is on now. Gonna connect it. So the software defined radio is on now. Gonna connect it. Alright, so let's see. As you can hear. Alright, so the software defined radio is on, and as you can hear, the transmitter is actually working on 27 megahertz. So I can unplug the amplifier. Right. So I can unplug the amplifier because we don't need it anymore. Alright everyone, so that's it for you today. The wireless microphone or the radio transmitter from few components. A preamplifier modified slightly with a crystal and a capacitor. Works from 3 volts, but it can also work from 3.7 volts. We show that right away. And then it can also work with 1.5 volts. Very stable system right here. Frequency is stable versus the previous transmitter we built right here, which is voltage controlled. So the frequency depends on the voltage. But the one we have right here today, the frequency depends on the crystal. So as the voltage falls for this new system, the frequency is stable. For this other system, the voltage fluctuates. And I have given you a way to overcome this. The problem with this voltage controlled oscillator is to use a voltage regulator and a slightly higher voltage than the threshold voltage of the voltage regulator, so that you can keep the transmitter frequency fairly stable over a longer period. But the one we have today doesn't require a voltage regulator. Just use your crystal. Try different crystals. Use a higher frequency crystal. And again, this is a very short, low power transmitter. So for us to use this in our subsequent project, which is a walkie-talkie, it's going to be further down the road. But when we get there, we're going to have another amplifier stage, an RF amplifier stage, probably a filter to remove the harmonics, and then that will be it. We'll build 2 sets of it, and we have ourselves a good walkie-talkie. You can try it yourself. We have shown you how to build an FM receiver using just one transistor. You can build that out and then build this transmitter, stable frequency, and just pay them. Make sure that the resonant frequencies correspond, and using a tuner, variable capacitor, you can tune to this frequency. Remember, what you need is the inductance and capacitance to correspond to the resonant frequency of this crystal, and that will be it. Low power. If depending on the area you are, you might require a license if you want to build a high power transmitter. But for a low power transmitter, or even if you want to use it in the region we are using right now, 27 megahertz, I think it's a pretty free frequency band or frequency allocation. You can use it for your experiments. All right, thank you so much. And subsequently, we'll be coming your way with some digital electronics. We are already switching gears a little bit. We're gonna go digital shortly. We'll be coming your way with Node MCUs, ESP32 and ESP8266. We're coming with lots of loads of projects, your IoT designs and devices, and all that, home automation and the rest of them. All right, stay tuned. Please subscribe to this channel. Tell your friends. Remember to like this video and hit the notification bell so when we post next videos, you'll be one of the first to know. Alright, thank you so much. I appreciate you. Bye. Alright. We're signing out for the day. A simple transmitter from just a few components. Modifying your preamplifier with two components. Two components. Who will believe that? Two components from a preamplifier gives you a stable frequency transmitter right here. This is just an added bonus, right? Just to control the volume. But other than that, two components, a crystal, a capacitor across a preamplifier gives you a transmitter, stable frequency transmitter. Solder this up and see how it works. Alright, we've done soldering on this already. Very beautiful design. So try yours. Let us know how it works for you. Alright, this is what we use in our soldering techniques video. Solder yours up. Very beautiful, elegant design. Alright, I'll see you in the next one. Bye bye.